we mentioned earlier that in steady state, the temperature along the rod has already stabilized. So the temperature along the rod will not change with time. So over here, we mentioned that the temperature at all locations along the rod is constant with time. It's not constant across the whole rod. Okay, this is something important. If we are not saying that the whole rod has the same temperature, what we are saying is that the rod here, the temperature at all positions, they have different values, but those values will no longer change with time. This is what we are trying to emphasize here. It is constant with time. Okay, so temperature at all locations along the uniform rod has no longer changes. So you won't see any rise in temperature, you won't see any drop in temperature at any point on the rod. Okay, so if we say something experiences no change in temperature, that means there is no increase or no decrease to the internal energy of that location. Okay, so every location along the rod stores some internal energy. So if your internal energy at a certain position increases, it will cause your temperature to increase. Whereas if the internal energy at a certain position decreases, then you experience a drop in temperature. But because we know that the temperature no longer changes with time, that means that every position along the rod, there will be no increase or decrease of internal energy with time. The internal energy at every position along the rod will remain constant with time, will no longer changes with time. So all locations in the uniform rod experience no gain or loss in internal energy. Okay, so they may have different amount of internal energy at different position, but every position the internal energy will no longer changes with time. Okay, so if that is the case, that means that the amount of heat transferred into and out of each location per unit time is equals in the uniform rod. Okay, so every position on the rod will receive some heat from one end of the rod, and it will pass the heat to the other end of the rod. Okay, because heat flow is flowing in a certain direction, right? So it will receive heat from one direction and it will pass on the heat to the other end of the rod. So we consider there's heat coming in to that position and there's heat going out of that position. So if we say the internal energy at that position is not changing with time, that means if I receive how much heat at that position, that how much heat that I receive will need to be given out as well in order for us to not experience any gain of energy or loss of internal energy. Let's put in a diagram to explain things better. So this is a uniform rod that I have here. I imaginarily cut this uniform rod into a few sections, 1, 2, 3, 4, 5, 6, 7, 8. So I know that my rod, this section of the rod will be higher in temperature, whereas this section of the rod will be lower in temperature. But what I know is that at steady state, the temperature here will not change, the temperature here will not change, 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 will not change. They have different values, but they will not change. Okay, so that means the internal energy stored here is not changing. I'm not experiencing any increase in internal energy, not experiencing any decrease in internal energy. Same over here. They have a certain value which is different from this section, but the internal energy here is not increasing, not decreasing, not increasing, not decreasing. They all have different amount of internal energy, but they are not increasing, not decreasing. Okay, so if I say that the internal energy over here is not increasing, not decreasing, that means if I receive how much energy from 1, the heat that comes from 1 that enters 2 will need to go to 3 as well. Okay, if I receive 5 joule of heat from 1, I will need to pass on that 5 joule of heat to 3. Okay, so that I will not hold on to any energy that I receive, or I won't give too much energy to number 3. So by doing that, if I take out how much energy, I pass how much energy to the right, that means I'm not having any increase or decrease in internal energy. By that way, my temperature will not change. Okay, so because of that, we know that the amount of heat transferred into one section and the amount of heat transferred out of one section must always be equal. So all these arrow here represent the same amount of heat being transferred in or being transferred out of all positions of the uniform rod. Because of that, we can say that the temperature no longer changes. So T, the temperature, will not change with time. t. So dt is equals to 0. That's the idea of steady state. Okay, what I want to highlight here is that the amount of heat transferred into and out of each location is equal. So how much heat enters here in 1 second? It's equivalent to how much heat going out of here every 1 second. How much heat enter here 1 second is the same as how much heat going out of here every 1 second. And every single arrow here have the same amount of heat transfer in, have the same amount of heat transfer out per second. Okay, so that's the idea of steady state.